Welcome to Matematika. Today we're going to do problems and solutions of 1.11a, equivalent representation of polynomial and rational expression. We'll start with A. Divide the following using long division and synthetic division. By looking at number 1, since the divisor is a polynomial, then might as well we are going to use the long division. So setting up, we will write the 2x to the third power. First of all, we have to inspect that the place order is, everything is there. So 3, 2, 1, so it is in place order. So 2x cubed minus 2x squared plus 10x minus 3, you divide by x squared plus 3x minus 2. Okay, let's start. So the first step you're going to do, use the first term of your dividend divided by the first term of your divisor. So let's make our trial here. 2x cubed over x squared. So what is left is 2x. You cancel out, then you have 2x. Okay, you gotta write the 2x here at the top where the x to the first degree is located. Then multiply back 2x times 2x squared, that is 2x to the third power. 2x times 3x, that is 6x squared. 2x times negative 2, that's negative 4x. Alright, subtract. Then change the sign. This will become negative, that will become positive. So you cancel out the first term. Then negative 2 and negative 6, that's negative 8x squared. 10 plus 4, that is 14x. You bring down the last term, minus 3. Then make your first term again, do the same process. Negative 8x squared, you divide by x squared. What is left is negative 8. You cancel that out. Alright? And then multiply back. That would be negative 8x squared. Negative 8 times 3, that's negative 24x. Alright. Negative 8 times negative 2, that's negative 16. That's positive 16. Okay? Alright. Then subtract. So change the sign. Everything here. So 14 plus 24, that's 34x. At 38, sorry for that. The negative 16, negative 3, and negative 16, that's negative 19. So this is our remainder. Alright. So our answer here would be 2x minus 8, then plus 38x minus 19. We cannot simplify that anymore. Then we have over x squared plus 3x minus 2. That's the answer. Well, looking at number 2, the first thing I look at when it's a division, I look at the denominator. I always look at the divisor. So the denominator is linear. Then might as well, it will be easier for us to use synthetic division. By getting the divisor, you equate that to 0. So x is equals to 3. That will be our divisor. Now let's look at our dividend there. X to the fourth, x to the second power, x to the first minus 4. There's a missing order. There's a missing placement. Okay? Missing term. So x to the third is missing. So we're going to have it as x to the third. The coefficient here is 1. So I'm going to write 1. Then x to the third, it's 0 x to the third. Then we have x to the second power. The coefficient is negative 4. Then we have a negative 6. And then the constant is negative 4. So let's bring down 1. So 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 4 plus 9 is 5. 5 times 3 is 15. 15, negative 6 plus 15, that's 9. Right? Okay. 9 times 3, that is positive 27. That is 23. Okay, let's write down our answer. Take note that our answer, the first term should be 1 degree lower than the given polynomial. So 1 should have x to the third power. Then 3 would have the second power. Plus 5 would have the first power. Then plus 9 as the constant. And the remainder is 23 over x minus 3. And that is the answer. Use the graph of f to write the equation of the slant asymptote. I think we talked about slant asymptote in our previous video, but I'm going to review it again, what a slant asymptote is. So actually, a slant asymptote is like an oblique asymptote because it's oblique to the left or oblique to the right. And it's slanted. Okay, it is slanted. That a graph approaches but never touches as the inputs approach infinity, positive, or the negative infinity. When does a slant asymptote occur? When the degree of the numerator polynomial is exactly one higher than the degree of the denominator of the polynomial. Okay? So let's go over these slant asymptote questions right here. You are asked to give out the equation. All right. You can I will blow this up. You can have the equation by using how do you call this? Using the slope of the line. Okay. So let's do this. Okay. The broken line, this is our slant asymptote. All right. So I'll start. Okay, I'm going to use some color here. So let's start with where the line intersects in the y-axis. Because if we write that, the equation, we could find the y-intercepts right away. And from the y-intercept, we could start counting and looking for, and writing down and looking for the slope. Okay, I'm going to use this point right here, where it exactly hit the x and the y-axis. This is by looking at the graph. Or I could use this point right here. Okay, I'm going to use this point. So from the slope, from the y-intercept, I mean, it goes down 1 and over 1, 2, 3, 4, 5. Okay? It goes down 1 and over 5. That means our slope, since it goes down, it's negative, goes down 1. Remember, slope is rise over run. So I'm using rise over run here. And over 5. X minus our y-intercept is minus 2. So this is the equation of the slant asymptote. All right. Let's do the second graph. Okay, our slant asymptote is this. Right? We're going to find the equation of the slant asymptote here. So where does it intersect in y? Right here in this point. So I could write like y equals. Okay, so -1, from -1, I'm going to choose some point here. Okay, about this. It exactly hit the x and y axis. So from -1, it goes down 1, 2. Goes down 2 over 1, 2, 3, 4, 5. Over 5. So our slope is -2 over 5 x, and our y-intercept is -1. And that's the equation of the slant asymptote. I hope you could look at that way when slant asymptote is being asked. Let's do the third question. Determine if the following function have a horizontal asymptote or a slant asymptote. Remember, there are 3 cases when we look at the horizontal asymptote. When the degree of numerator is less than the degree of denominator, when the degree of the numerator is equals to the degree of the denominator, or when the degree of the numerator is less than the degree of numerator. But slant asymptote, the degree of the denominator is 1 less than the degree of the numerator. Okay? So in this case, in number 1, our degree here is 4 if we look at that, and the degree is 2. So it's higher, but it's not 1 higher than the degree of the denominator. That means it does not have both the horizontal and slant asymptote. So this is the answer to that by looking at that. Okay? F of x is 2x to the 4th. I'm looking at the first term and fifth. So the degree of numerator, say m, is less than n. Okay. It goes with the first case or third case of the horizontal asymptote. But we're not looking at what is that asymptote so long as we know that there is a horizontal asymptote in this case. Okay? It's not slant, does not have, because there is a horizontal asymptote. For number 3, x to the 3rd and x squared. See this? The degree of the denominator is less than the degree of the numerator. That means the numerator is greater than the denominator. That means that we have a slant asymptote here. Okay. We write the equation of the slant asymptote. Remember that in slant asymptote, we need only the first two terms. Okay, so let's do this. 9x to the third power minus 12x squared minus 5x plus 1 divided by 3x squared minus 2x. Okay, if we're gonna do long division, okay, let's do the long division here. 9x to the third, 12x squared minus 5x plus 1. We know there is slant because the degree of the denominator is greater. So we can use, okay, I need some space right here. Okay, I'm gonna do this here. 9x to the third minus 12x squared minus 5x plus 1. You divide by 3x squared minus 2x plus 1. Okay, my first trial would be the first term. You divide by the first term of your divisor. So 9 divided by 3 is 3. X squared cancel out. That's 3x. So we have 3x right there. So multiply back 3x times 3x squared. That's 9x cubed. 3x times 2x, that is 6x squared. 3x times 1, that would be plus 3x. Okay, subtract, change sign, cancel out. 12 plus 6, that's negative 6x squared, minus 8x, bring down 1, plus 1. Then let's make a trial of negative 6x squared divided by 3x squared. That would be cancel out the x squared. Negative 6 divided by 3, that is negative 2. If we multiply it back, we have plus 4x minus 2x. Actually, in this case here, we are done. I'm just showing the finished product here. This would be negative 12x and minus 1. This is the remainder. By getting the slant asymptote, our concern is this, not the remainder. So we have our equation for the slant asymptote as 3x minus 2. Disregard the remainder. Let's have number 2. This is linear. The denominator is linear. Might as well we can do the synthetic. X plus 4 equals 0. So our divisor would be 4. Okay, everything is in order. So the coefficient is 2. 9, 6, bring down 2. 4 times 2, it's 8. 9 plus 8 is 17. Wait, I'm looking. This is negative 4, sorry. So I'm looking. Negative 8. So this will be 1. And then 1 times negative 4, that would be 2. So 1 degree higher, lower, that would be 2x plus 1. This is the, regardless of this, because that's the remainder. Okay, in slants, we don't need the remainder in slants. Okay, this is the equation for slant. Let's have this multiple choice right here. Okay, The function is a rational function. The quotient and remainder form is of f is given by f of x is negative 2x plus 1 plus 3x plus 4 over x squared minus 4x minus 2. Okay. What would be the limit notation of this? So if we try to look at this, let's say, looking at this, we could say, okay, this is the slant equation. Okay, that's a slant equation. Oh, my handwriting is awful. So it intersect positive 1, and the slope is negative 2. That means negative 2 over 1. It goes down by 2. This is what? 1. And then we have this here over negative 2. Or we go up 1 and then to the left 2 right here. So we can have our equation right here. I mean the line for slant. Okay, so this is our, since the choices are talking about infinity, this is positive and negative infinity. What happened to our function? So as x approaches negative infinity, is it negative infinity? No. From there, no. Limit of x as approach negative infinity, that's positive infinity. And then if it approach positive, is it positive infinity? It's no right here, because this is negative infinity right here. In letter C, if x approach negative infinity, it's negative infinity, wrong, because it is positive infinity. If x approach negative infinity, f of x is positive, correct? If x approach positive infinity, it is negative infinity, correct? So therefore, our answer is D. Which of the following is equivalent to x squared plus 5x plus 2 over x plus 5? If we look at our choices, remember, when you have a multiple choice, look at your choices before you answer. Think about what are the choices is talking about. So it's talking about, more or less, if you can see, it's talking about division. Since it's linear, it's much easier for us to do the synthetic division. Try to check. If this is x plus 5 equals 0, then x is negative 5. And then it is in order, so our coefficient is 1, 5, and 2. Bring down 1. 1 times negative 5 is negative 5. Plus 5 plus negative 5 is 0. 0 times negative 5 is 0. 2 plus 0 is 2. Okay? So this is 1 degree lower than this. So it should be 1x. Okay, the next term is 0. This is the remainder. So it should be plus 2 over x plus 5. So which one of this gives us x plus 1? No. X plus 2? No. X plus 2 over x plus 5 regardless of the 0. This is the one because this is not the remainder for D. All right, you have the answer there. For 3, the function f is given by f of x equals 6x squared plus ax plus 2 has a slant asymptote of y equals 6x plus 3. What is the value of a? Okay, slant asymptote is given. Okay, so thinking about that, that is this is the more or less the quotient because that's the slant asymptote. So if we place, let's say we place, okay, let's do this. I want to do something like doing it in how do you call it? Synthetic division. So I have x plus 3 equals 0, x is negative 3. Let's do this. So they are in order. So the coefficient of x squared is 6. Coefficient of x is a. We are asked what is the value of a. So a is here. And then we have the constant 2. Bring down 6. 6 times negative 3, that's negative 18. Okay. A plus negative 18 is what? A plus negative 18 is what? What would that be? Okay? Regardless of whatever our remainder. We're not thinking about it because we are talking about slant asymptote here. Now remember, the slant asymptote is given. Y equals 6x plus 3. Okay? Y equals 6x plus 3. We have the first term, but we are looking of that value that equates us to A. And it says that that value should be that 3. Okay? So what happened if A plus negative 18, that would be equals to 3. A would be 3 plus 18. A would be equals to 21. Okay? So therefore, this number, when you subtract it with 18, it will become a 3. Because our equation for the slant asymptote is y equals 6x plus 3. And 3 is the second term. Second term here of the slant asymptote. So we are talking about what should be the one that equates to the second term. Okay? This is somewhat like you have to think about something that you can resolve for finding missing variable. Okay. 4. What is the remainder? So we are talking about the remainder this time. Always remember when we speak about remainder, think about, the remainder theorem. Okay? When we divide polynomial, the f of x by x minus c, the remainder should be equals to f of c. Okay? So, when 3x squared minus 5x is divided by x minus 2, so in this case right here, 3x squared minus 5x plus 6 divided by x minus 2. So from the remainder theorem, we're gonna find like what happened if we equate this to 0. X would be 2, and try to check if there is a value for our remainder. Okay, so replace 2, 3 times 2 to the second power, replace that to the polynomial, plus 6, that is 3 times 4, that is 12, 5 times 2, that's 10, plus 6. Then our value is 18 minus 10, that is f of 2 is 8. That means 8 is the remainder of the function. Okay. Okay, number 2. 2 is a root of k x to the 4th minus 11 x cubed plus k x squared plus 13x plus 2. What is the value of k? Okay. How about you have 2 is a root. So what you're going to do is to make that function f of 2 and replace that to the polynomial given and find that value of k. 2 to the 4th minus 11 2 cubed plus k x squared, so that means 2 squared, plus 13 times 2 plus 2. Okay, 2 to the 4th is 2 times 2, 4 times 2, 8 times 2, 16k. 2 cubed is 8 times 11, that's 88. And 2 squared is 4, that's 4k. 13 times 2, that's 26, plus 2. Okay, let's simplify. 16k plus 4k, that is 20k. Negative 88 plus 26 plus 2, that is negative 60. Okay, so if we move 60 to the left to make it into a positive, and then divided by 20, k would be equals to 60 divided by 20, that is equals to 3. Okay, right here. Which of the following is a factor of 6x cubed plus 5x squared minus 2x minus 1? Okay. Which of the following is a factor? So we'll try to figure out if I can do by grouping. If I can, like, if I group 6x cubed plus 5x squared, if I group that, and I have this group as 2x plus 1, what's gonna happen is I pull out x squared, I have 6x plus 5. And still, I cannot get a common factor. I cannot get anything from it. If you encounter a problem like this, the best thing you do is to look at your choices. And you have to be sure. From doing that, with your choices right there, I'm going to erase this. That's the way you can find the factor, because it's the choices. You have a x minus 1, so maybe if you do x minus 1 equals 0, x equals 1, you make that and you substitute that to the given polynomial, and about 2x minus 1 equals 0. So 2x is 1, x is 1 half. How about the other one, 3x? Look at your choices. See, it's already in patterns. The one who gave you this question is trying to find out whether how you're going to solve the problem, right? So x is 1/4. So you're gonna try. What happened if the function is this 1 half, 1/3, or 1/4? So let's gonna do this. If it is f of 1, okay, remember that if it is equals to 0, then we have a factor. If it's not equal to 0, then it's not a factor. Okay, so I substitute x equals 1. So 6 times 1 cubed plus 5 times 1 squared minus 2 times 1 minus 1. Okay, so 6, whatever you have the power of 1 is still equals to 1. So 6 plus 5 minus 2 minus 1. 6 plus 5, that is 11, minus 3. What's 11 minus 3? That's 8. 8, 9, 10, 11. So you have 8. And 8 is not equal to 0. Right? 8 is not equal to 0. So therefore, x minus 1 is not a factor of what is given here, of the function of x. Okay, let's do the second one. What happened if it's 1 half? So 6 times 1 half cubed plus 5 times 1 half squared minus 2 times 1 half minus 1. So 1 half cubed is 1/8, right? 1 half squared is 1/4. 2 times 1, 2/2. I'm just showing. Minus 1. So this will become 6/8 plus 5/4. 2/2 is 1 minus 1. All right. Let's have a least common denominator here by 8. So 6. 8 divided by 4 is 2. So 2 plus, times 5, it's 10. 8 divided by 1, it's 1 times 8. Times 8. Okay. 6 plus 10, it's 16. Minus 8 minus 8, it's 0. Over 8 is equals to 0. Therefore, okay, therefore, we could say, this is the one, we could say that x, 2x minus 1 is a factor of f of x. Is a factor. So our answer is already this. Let's try, you want to know, and let's try 1/3 to find out. If f to the 1/3, f of 1/3, so 6 times 1/3 cubed plus 5 times 1/3 squared times 2 times 1/3 minus 1. So 1/3 is 1/27, so this is 6/27. 1/3 squared, that's 1/9, that's 5/9. Then 2/3 minus 1. So let's have the LCD of 27. So this will be 6. 27 by 9 is 3 times 5, that's 15. 27 by 3, it's 9 times 2, 18. And 27 by 1 is 27. Let's see if it's equals to 0. 6 plus 15, that's 21, minus 20, minus 18, minus 27. For sure, this is not equals to 0. And the same thing is gonna happen. Let's do the 1/4. So 6 to the 1/4 cube. Do the process. To the 1/4 squared minus 2 to the 1/4 minus 1. So 4 cube, that is 4 times 4, and times 4, that's 6/64. And 5/16 minus 2/4 minus 1. Quietly sure this is not equal to 0. It's very visible. And you found out the answer already in the choices. It's not even asking how many factors that is there. What is a factor? So you have only one. But we are just checking if some answers will come out. But actually, the way we see it, when we substituted the value, it's not equal to 0. Okay. So much so, we have a lot of problems and solutions that we went over, and I hope this helps a lot when you will be taking the AP Precalculus. Okay, let me say this. If I can do it, so can you. Please don't forget to hit the like button and also subscribe if you haven't subscribed yet. See you in my next video.